In this video, we are once again going to determine the end behavior and the horizontal asymptote of a rational function just by looking at the equation. So what we're looking at to determine end behavior and horizontal asymptotes is what happens as x approaches infinity and as x approaches negative infinity. So we are looking at, in the graph, we're going to be zooming all the way out. We're looking for horizontal asymptotes. We could plug in very large values of x and see what happens. But in this video, we're going to look at the idea of how does this function, just looking at the equation, tell us? So we pick the term that has the most effect on the graph in the numerator. So that's 5x cubed. As x gets closer to infinity, the adding x and subtracting 1 become almost irrelevant. In the denominator, we have 2x squared as the term with the largest effect. If you're thinking about degree, the degree in the numerator is 3, the largest exponent. The degree in the denominator is 6, largest exponent. So therefore, again, this is only a true scenario as x approaches infinity and negative infinity. This isn't math we can just do. But this function f of x would be approximately 5x cubed over 2x to the 6th. Okay. From here, we could simplify. We have 3 x's in the numerator. We have 6 x's being multiplied in the denominator. So we have 3 x's that would make giant ones, and we would be left with 5 just 5 over 2x cubed. So there would no longer be any x's in the numerator. Let me write that again down here. There would no longer be any x's in the numerator. So as x approaches infinity, as x gets larger and larger and larger, so we have 5 divided by a number that's going to be huge. Okay, huge is obviously not very precise, but we are taking 5 and dividing it by the largest number you can think of and then raising that to the 3rd power. So if you take a small number and you divide it by a very big number, it's going to head to 0. Okay, so the larger the denominator gets, the closer that this fraction gets to 0. Since we're headed to 0, it doesn't matter whether the number we're getting is positive or negative. They're both getting 1 in one direction, positive infinity, in the other direction, negative infinity. They're both getting closer to 0. So the end behavior of this function, because the degree in the denominator, the exponents in the denominator were larger than the numerator, this function is going to be heading to 0 as x approaches infinity and negative infinity. Therefore, it has a horizontal asymptote of y equals 0. What's nice about this is now next time you see a function where the denominator has an exponent or a degree, the largest exponent in the denominator is larger than the largest exponent in the numerator, you know the horizontal asymptote is just y equals 0, and you don't have to kind of do any of the other steps.